Hi kids, we will be going with this paper discussion. You can look at the first question. Near a very long straight wire carrying a constant current, there is a rectangular conducting loop. Long side of the loop is parallel to the wire. If the loop is rotated by an angle of 180 degrees around the side farthest, so when you are rotating about this, charge q1 will pass through it. If instead of rotating the loop, you just move it in such a way that this one will come here, then the charge passed is q2. Then what is the charge passed if the loop from initial position is carried to a large distance? So basically when you are moving it, there will be motional EMF, so there will be current and all in the rectangular loop. Now if you want to understand that, you will be writing loop equation for that rectangular loop, then you will be integrating. Now current in the rectangular loop initially and finally is 0, so charge flown is going to be change in flux by R. So it doesn't matter how fast you are rotating or how fast you are moving, charge flown is going to be same because change in flux is same. So all we need to do is calculate change in flux. Now initial scenario is like this, where suppose this distance is L, then this is L plus A. Then if you want to find the flux through this, you will be taking a strip, you will be finding the magnetic field there and multiplying with the area there, then you will be integrating from here to here, L to L plus A. Similarly when you rotate it, the scenario is like this. If I want to talk about magnitude of flux, again I will be doing the same thing, but integration limits will be from L plus A to L plus 2A. Now understand one thing, if I take area vector is in this direction right now, now when I flip it, that area vector will be this way. So if I take initial flux is positive, final flux is going to be negative when I rotate it. So change in flux is going to be final minus initial, magnitude wise it is going to be addition of both of them when you rotate. When you rotate, change in flux is going to be addition of magnitude of both of them. But instead of rotating, if you simply slide it, then area vector will be pointing in the same direction. So change in flux is going to be magnitude wise difference of their magnitudes. So change in flux is going to be different of their magnitudes. Now multiply with 1 by R, then you will be getting the charge flown according to equation what we have seen. So this will be the charge flown in the first case when you are rotating, this will be the charge flown in the second case when you are moving. Now when you take it to infinity, change in flux is this much. When you multiply with 1 by R, you will be getting charge flown out. Now you can easily understand this value is nothing but summation of these two and divide by 2. A tennis player uses a racket to hit a ball over a net. When the racket strikes the ball, the frame is set into oscillation. The fundamental mode of oscillation is shown. Transverse pulse speed is given. Calculate the frequency of oscillation. So it was, everything was given there. Lambda by 2 is given as 45 centimeter. From there you can find lambda. V value is given in the question. From there you can find what is the frequency of vibration. Optical activity is a phenomena exhibited by medium where linearly polarized light continuously rotates in the plane of polarization as it passes through the medium. So they were telling to distinguish clockwise or counterclockwise, what we should be doing is, if the plane of the electric field appears to have revolved clockwise, then the substance is called as d-rotatory. If it is seen as rotated counterclockwise, then it is called as L-rotatory. And they have given electric field before and after, then they were asking d-rotatory or L-rotatory and what is the rotation of the plane polarization. Wave is traveling along negative x-axis, so I am taking this as negative x-axis. In order to take this as negative x-axis, I have taken this is positive x-axis. So I cap cross j cap is k cap. So I have defined my coordinate system like this, such that I cap cross j cap is k cap. This is j cap, this is k cap, this is I cap. So wave is coming this way. Wave is coming this way. Now if you take sin kx plus omega t common, then you will be getting minus 6 I cap, minus 6 j cap and 8 k cap. Minus 6 j cap and 8 k cap, that electric field will be oscillating along this line. Now what about this angle? That is going to be minus 6 and 8. So tan theta is going to be 6 by 8. So that angle is going to be 37. Now after you can take 3 sin kx plus omega t common, then you will be getting j cap plus root 3 k cap. Anyway, I am just writing unit vector so that you understand better. So j cap plus root 3 k cap, that was along this direction it is root 3 and along this direction 1. So that angle tan theta is 1 by root 3, 30 degrees. So initially electric field is oscillating this way in this line. Later on it is oscillating this way. You can see here it has rotated counterclockwise. You can see here also it has rotated counterclockwise. By how much angle? 67 degrees. So it is going to be L rotatory and rotated by 67 degrees. A microphone records the sound generated by two loudspeakers that emit sinusoidal sound waves of frequency F1 and F2. Which statement is correct? Now, I don't think you can differentiate between interference phenomena and beat phenomena. Anyway, so by looking you would have understood that question has something to do with beats. So when is this figure going to happen? You would have seen when there are two waves interfering with slight difference in the frequencies. Slight difference in the frequencies, when omega 1 and omega 2 they were almost equal, the difference is very small. In that case, yeah, when you do some math you will end up getting some expression. So basically that expression is going to look like something like this, or when this is very small and this is big, maybe if I take an example it looks like this, whose figure is going to look like this. Now if I try to plot this figure, if I show you how you have to do it, you will be looking into which is varying slowly, which is varying quickly. This part is varying slowly, whose graph looks like this. This part is varying quickly, whose graph looks like this. Now the product is going to look like this, as if you have drawn an envelope again here and this is fitting inside that. So envelope will be decided by slowly varying function, whatever fitting inside is by the fastly varying function. Fastly varying function is omega 1 plus omega 2 by 2, which was almost omega we have taken, omega 1 plus omega 2 by 2, omega 1 minus omega 2 by 2. But for beat frequency, we don't need full wavelength, this is going to be beat frequency, so we will be getting f1 minus f2 instead of f1 minus f2 by 2. Now understanding that, so you will be hearing a loud sound here, then here the gap is 100 milliseconds, so you will be hearing one beat in 100 milliseconds, so beat frequency is 1 by 100 milli, that is going to be 10. Anyway, that's not much needed. That difference is small. The difference is small. That should make sense from the figure itself. The difference is small, but each value is going to be much greater than 10. Now, if you zoom in, this figure is responsible by the quickly varying function. Quickly varying function was of the format omega 1 plus omega 2 by 2, which is almost omega. Now, if you see from here to here, there are roughly 20 waves in 20 millisecond. So how many waves in 1 millisecond? That is going to be 20 by 20 milli. That is going to be roughly f, which is 1000. 1000 is much greater than 10, which was expected when you see the figure this way. A plano concave lens made of a material with a refractive index 1.50 is placed on a flat glass plate as shown in the figure. The radius of curvature of curved surface is 8 meters. The lens is illuminated with yellow light from sodium lamp whose wavelength is 600 nano, and concentric bright and dark fringes are observed. The interference pattern has a dark spot at the center while surrounded by dark rings. Now you should understand it is spherically it is symmetric about this axis, right? So you will be expecting by as it is circular symmetry, so you will be expecting the fringes will be circular fringes. Then they were asking thickness, magnitude of focal length. Now you can see the radius of the lens is 8 meters. So when you try to find the focal length of the lens using mu minus 1 by f equals to mu minus 1 into 1 by r1 plus 1 by r2, you will be getting negative value as well as you will be getting 16 meters. So option B is going to be wrong. Then let us see what is going to, let us evaluate A, then we go for C or D. And I already attached Newton's rings in some of the exam. I am attaching the same PDF here, but this is slightly, I mean its on mechanism is going to be the same thing. So what happens is, now this thickness is bigger, so we don't bother about the light reflecting from here. So only when the thickness is small and when they are interfering, we will be able to see that interference pattern. So we will be bothered about the ray which is hitting here and reflecting, there won't be any phase change, and partially refracted which is getting reflected, there will be a phase change of pi, right? So we need to see interference pattern between these two and the angle approximately when we take 0. So the path difference is, this guy is traveling this much, that is if this thickness is t, that is varying from here to here. So this ray is traveling 2 times of t extra and with extra phase difference of pi here. So when compared to this guy is having an extra dip. Now let me talk about here. So in this case, one ray is getting reflected from here, one ray is coming here, reflected from here. So the ray which came here, it is traveling an extra distance of 2 t naught, if this gap is t naught pixel length, and there is an extra phase change of pi. So when you try to include, then this is optical path and this is extra phase change. Now they said it is dark, so it should be, the path difference should be equals to odd lambda by 2. From the 2 t naught should be even lambda by 2, even lambda by 2, and they said it is 50th one, it is 50th one. So even by 2 will be integer, right? So that will be integer and it should be 50. So from there you will be getting this thickness is 15 micro, which is option A. Then we need to inquire about the end. At the end, that is 0, that is 0. In general, if you want to find thickness at any location, so if I want to find this thickness that is less than t naught, how much less than t naught? For that you will be drawing the circle for which sphere it was fitting in of radius r. Then you can use Pythagoras theorem and you can see that small length lefting out to be root of r square minus r square, as this is much smaller than this. You can use binomial approximation and you can see this small gap is r square by 2r. So this is going to be t naught minus r square by 2r. And okay, so I don't think you have to do this. Now when will this thickness become 0? When will this thickness become 0? For what radius that thickness will become 0? When you substitute, you will be getting root of 2r t naught, root of t r t naught. So the meaning is this radius is root of tr, root of 2 t naught r, root of 2 t naught r, which is 1.54 into 10 power minus 2. Understand the things which are coming here, there is no extra path difference, but one guy will be hitting here and going back, so there will be extra phase difference of lambda by 2, so it is going to be a dark fringe there. The electrical circuit consists of 10 identical voltmeters. The reading of voltmeter 1 is 12 volt. Then they were asking what is the reading of other voltmeters. So this current I naught will be splitting into two equal parts. That's very easy to see. After this, if you want to understand how it is going to split, then you can take this is I1, this is I2. I1 into 2R should be equals to I2 into R, and I1 plus I2 should be equals to I naught. From there you can see this will be I naught by 3, 2 I naught by 3. Similarly, current splitting I naught by 4, 3 I naught by 4. Now looking at the options, reading of voltmeter 2 is I naught by 2 into R. I naught into R is 12, so this is going to be 6. Then voltmeter 4, I naught by 3, I naught by 3 into R, that is 12 by 3, which is 4, option B is wrong. Voltmeter 6, I naught by 4 into R, that is 12 by 4, which is 3, option C is correct. Potential difference between A and B, A is here, B is here. So this potential difference is 2 I naught by 3 into R, that is 2 by 3 times of 12, that was 8. Similarly, this one I naught by 4 into 2 R, which is 12 by 4, which is 3. So potential difference between these 2 points is 11 units, right? This question already came in your current electricity unit test. So I am attaching the same PDF in case if you still have doubt, you can go back there. Charging and discharging. Two parallel conducting rails are connected to a source of EMF E and internal resistance R. Another conducting rod of length L having negligible resistance lies at rest and can slide without friction over the other rails. A uniform magnetic field B is applied perpendicular to the plane of the rails. At t equals to 0, the rod is pulled along the rails by applying a force F. The velocity of the rod is observed to be V naught cos omega t. Find the power spent by the force over one cycle. So it's a regular question. If I assume current is this way, because of which this force is going to come, and apart from that our applied force is also there and velocity is also there as a function of time. So at any time if it is like this, then there will be motional EMF in this direction. So net current at this moment is going to be E minus BLV by R, where V at this moment is V naught cos. Then similarly, if you write F equals to mf for this guy, ILB plus F should be equals to the rate at which this momentum is changing, m into dV by dt. Differentiation of this. Then so basically two equations were there. I need to find F. So I will be using this and I will be taking help of this equation. I will be borrowing from here and substituting here. Then I will be getting F, but they were asking power. Instantaneous power will be F into V, but for a cycle it is going to be like average only, or for cycle you can integrate, then this turns out to be 0. So for a cycle cos will turn out to be 0, sine 2 theta also will turn out to be 0. This is going to be half. Substitute the values to get the answer. 1 mole of ideal monoatomic gas is taken along a cyclic process. Process 1 to 2 is 1/4 of the circle, and isochoric is there, isobaric is there, efficiency. Work done is going to be area under this graph, that is area of this whatever rectangle thing. Rectangle or square you can say, but it should be of the dimensions P0 and V, P and V. So P0 into V0, and you need to subtract area of this thing, that is quarter ellipse. That is going to be the work done, and that is going to be positive work done. Positive work done is more than negative work done, so work done is going to be positive. Then okay, if I call this temperature as T0, from here P0, V0 and T0, pressure is becoming twice, volume is becoming twice, so temperature will become 4 times. Volume is becoming twice, pressure is remaining same, so temperature will become 2 times. So temperature is reducing, constant volume, so Q value is negative, NCV delta T. Q value is negative, NCP delta T. But we know for a cyclic process, summation of these 3 Q values should be same as this. From there, I can find this Q value. Summation of these, this and this should be equals to that. From there, I will be getting what is the heat taken by the gas or heat given to the gas. Then by definition, efficiency is this by this ratio. Two transparent slabs have same thickness as shown. One is made of material 1.5 refractive index, the other is made of thickness 1:2 ratio. Refractive index of C is 1.6. Then what should be the refractive index of B such that same number of wavelengths inside? See, same number of wavelengths inside is same phase difference. Same phase difference in the sense same optical path length. So it just has to be same optical path length. That's the reason we define optical path length. So this optical path length is 1.5 T. This optical path length is mu into T by 3. 1.6 into 2T by 3. Solve for mu. A ring of radius 1 by root pi, that is going to be area is 1, and negligible mass is rigidly fixed at the C of non-conducting rigid spokes were there which they didn't show. On non-conducting rod of length 5 meter and mass 2 kg, rod being axis of the ring and current 1 ampere flowing in the ring as shown. Rod resting against the smooth vertical wall while its other end is on the rough horizontal surface. Whole arrangement is placed in uniform vertical magnetic field. Given AC is 4, so anyway that's not needed. We already know this angle 37. Minimum value of mu so that the whole system remains in equilibrium. You understand minimum value of mu in the sense friction is going to be maximum in that scenario. So friction is going to be mu into N. When we draw the free body diagram, there is one contact here, one contact force, there is no friction, there is other contact force, there is friction. Now there is mg. Now magnetic force won't be there because it is a current carrying loop placed on a uniform magnetic field. So net force on the current carrying loop will be 0, but there will be torque, and torque due to those magnetic forces about any point should be same, because if we have some forces whose summation is 0, then torque due to those forces will be same about any point. So if I specifically talk about torque because of magnetic forces, they will be same about any point. And how much is that? That is going to be mu bar cross B bar. Mu bar is I into A, which will be 1 unit in this direction, and magnetic field is this way. So magnetic torque is going to be this way. About any point, if you calculate, the torque is going to be clockwise. And how much it is? M bar cross mu bar cross B bar, mu into B into sine of angle between them, which is going to be 16 units. So this is just for a representation, that is torque. It doesn't come in force equation. Now there are two vertical forces, two horizontal forces. So if I make net force 0 along the vertical direction, I can understand this normal is mg. If I make net force 0 in the horizontal direction, I can understand these two forces should be same. And under the critical condition, this friction is going to be maximum, which is mu into N, which is mu mg. So that is also going to be mu mg. I made net force 0 along x axis, y axis. Now the only thing is I need to make torque 0 about any point. I will take torque 0 about this point so that I can eliminate these two easily. And torque because of mg is this way, which is clockwise. Torque because of magnetic thing is also clockwise. So these two torques about this point will be adding up, and torque because of this is anti-clockwise when they will be equal, right? The only thing is understanding magnetic torque will be same about any point because net magnetic force is 0. A non-conducting ring of radius r having uniformly distributed charge q rotates about xx dash passing through the diameter. Another small conducting ring having radius much smaller than r is kept fixed at the center of the bigger ring such that x dash is passing through center and perpendicular to the plane. So the small ring is this way, that big ring is this way. So basically when you are rotating, their intention is for you to see the charge rotating this way on the ring, which is going to behave like a current carrying loop, which is going to create magnetic field. Though it's not exactly correct, we will be expecting it to happen. If it was constant omega, I understand. When omega is changing, I think it is slightly off. Anyway, we'll go with general way of doing it. We take some element. When that element, that charge is rotating, it behaves like a current carrying loop. Because of that, we'll find the magnetic field and we are going to integrate. For that, you should be aware of what is the magnetic field on the axis of the ring, which is going to be mu naught I by 2r times of sine cube theta. If I take some element here, similar element here, so they are going to contribute to current. It is going to behave like a current carrying ring. So the charge available is lambda times of 2r d theta, and after a time interval of 2 pi by omega, it is going to perform one rotation. So the average current is going to be charge available by time, mu naught I by 2 times of radius of the ring, which is r sine theta, into sine cube theta. That is the field on the axis of the ring. Then you have to integrate from where to where, all the rings, that is going to be theta equals to 0 to theta equals to pi. Then you will be getting some value. Now why is this important? So that you can understand what is the flux through this. Then rate of change of flux will give you EMF. When you divide with the resistance, you will be getting the current. And understand, it is not motional EMF, it is induced electric field. Magnetic field is varying with time, which is going to create induced electric field. The linear scale of a screw gauge can measure minimum value of 0.5 centimeter and there are 50 divisions on a circular scale. A vernier caliper is designed of same least count as that of above mentioned screw gauge. The main scale of vernier calipers is normal scale of 1 mm as minimum measurement. If the nth division of vernier coincides with 9th of main scale, then what is the value of n minus 1? Anyway, least count of the screw gauge you can understand 0.5 by 50 for one circular scale rotation. One circular scale division, it is going to read 0.01 centimeter, that is 0.1 millimeter, which is our regular vernier scale. So you don't have to even solve it, you can understand 10 VSD equals to 9 MSD. But if you want to solve it, you will be finding 1 VSD, then you will be finding vernier constant, and you will be expecting vernier constant is going to be least count here. Then n equals to 10, which should make sense as we already expected that. Okay, then in the next question, it's about gravitation chapter, ellipse. So you should be knowing something is performing elliptical motion, then its energy will be minus gmm by 2 times of semi major axis or minus gmm by major axis. So if something is performing this elliptical motion, then its energy will be given by minus gmm by major axis. Now when you are throwing with some velocity, it has some potential energy this much and kinetic energy half mv square. The total energy should be equals to this much. From there you will be getting with what velocity you will be throwing. Then time period of A, if you want to calculate, that will be proportional to t, that Ta square will be proportional to 2a cube. This is 2a, right? Circle is an ellipse of semi major axis 2a. If you want to calculate the time period of this ellipse, then it is going to be t square will be proportional to 9a cube, 18a by 2, right? From there you will be getting time period of the ellipse you will be getting, but you don't need time period of the ellipse, you need only half ellipse. They asked what is the time taken from here to here. So I am dividing with 2, that should give you the answer. Okay, in the next case there is an object here and image formed by this is twice the length of the image formed by M. Image formed by M, see, you should understand it is not exactly the thing because they were telling no parallax, so you can't understand that, but okay. So when they say no parallax, image is forming along the same line. So basically for this object, if this image is forming here, for this object, this image, because of this mirror also image will be forming at the same location. And this kind of questions you would have done lot many. So whenever the combination is like this, you can go with the effective focal length of mirror. So anyway, focal length of the lens will turn out to be 40. So if you want to talk about this, you can treat it as, you will be treating it as one lens plus one mirror plus one lens. Lens is converging, mirror is converging, so their powers are positive. So you will be adding their powers, you will be getting effective power is 1 by 10. 1 by 10. So it is going to behave like a converging mirror. It is going to behave like a converging mirror of focal length 10 centimeter. Then when you use mirror formula, focal length is minus 10. Understand? For converging mirror, focal length will be minus 10. When the object is at a distance minus a, image will be forming somewhere, but we already understood magnification is 2. And if you want to understand plus or minus 2, V value is already positive, we understood, because of the mirror image will form there. V is positive, U is negative, so overall will be positive value. When you substitute it back, you will be getting a value as 5. Once you understand a value is 5, then you should understand image will be forming at 10 here. So this distance is 15. If this distance is 15, then if you talk about mirror's image also, I mean because of the mirror also image should be forming here itself. So mirror should be exactly in the middle, which is 7.5. That is, this distance is 2.5. This distance is 7.5.